Good evening. It's Mike for Faraday Research here, live from Toronto. It is Friday evening, and I also have Gerald. I keep saying Gerard. Why do I do that? He's live from the prairies or Winnipeg, and we're all in a deep freeze here in Canada right now. About minus 18 degrees, and then it's like minus 20. So with the wind chill, so it's not very comfortable, but it might be cold outside, but it's going to heat up tonight with our discussion. And none other than Gerald's with me tonight. He's the man with the coils. And if anybody knows coils, it's him. And we'll get into that. And there's another topic that came across my table late this week about what's called as a Moxie fusion reactor.
Interesting.
And apparently it's been out for quite a while. We're talking over 50 years. Some guys have been working on it in the last 20 years. And this reactor has some pretty interesting effects. One, create a excessive amount of power the amount of power that you put into the system, you're getting way excessive output power. So that's intriguing all in its own. The other incredible properties of this fusion reactor is making exotic metals. One of them is platinum, gold, silver, copper, zinc, and much more. So, depending on what metal that you put into the reactor, say if you want to make gold, this two guys, I believe they're in Italy, they were experimenting with tungsten oxide. Put that into the system with an anode and a cathode, pressurize it with argon at 10 atmospheres, and zap it for about 4 to 5 hours. And at the bottom of the reactor, when you're done, will be gold.
Wow.
Yeah. So we have transmutation of metals happening in this reactor. Also, platinum. It depends what you put in, what type of metal that you put in. And you can experiment, but apparently tungsten oxide creates gold.
And what was the name of that reactor again?
Moxie, Moxy, fusion reactor. And I just seen a really good.
Sorry, go ahead, Mike.
I just seen a really good interview with Jay Widener. He interviewed the guy who's working on this device in the U.S. Here, I'm going to put the link.
I think I got it. It's called the Free Energy Oh no, wait, that's something different. Yeah, Free Energy Revolution. It's called.
Yeah, Free Energy Revolution. Yeah, Jay Widener just did an interview with him yesterday. I'm going to put the link.
Here, I got it in the chat right now.
Oh, you put it in? Okay, you beat me to it.
It's in the private chat.
It's in the private chat? Yeah. So, yeah, this reactor is, and the crazy part about it, remember back in the early 90s, you had Martin Fleischmann and the Pons, they were working on the cold fusion?
Absolutely.
Right. Okay, so when they did the fusion experiments, and get this is where it gets interesting. They were looking for radioactive isotopes being created in the reactor. They had tungsten or something in it, tungsten oxide. So they were doing the reaction, they were getting the results, they were getting a fair amount of power out of it. But they're looking around for radiation. But they didn't realize that the thing was throwing off a huge amount of X-rays. Both of them were being blasted by X-rays.
Wow.
Both of them died of cancer.
Oh, that sucks.
Yeah, they weren't aware that tungsten, when you do that gold fusion reaction to make gold, it emits a huge amount of X-rays. and they were
Oh, really?
blasted. Yeah. So if you were to do this experiment, you have to put lead shielding over the reactor, so those X-ray emissions will, you know, basically eat you alive and not even feel it.
See, I've been looking for something like I've been working on something. Actually, I've kind of showed bits and pieces it to Jeremiah Pop and Jeremy Reese as well. But I'm been working on the same type of transmutation through plasma and geometrical forms, and it's called like the end result is called the Mossbauer effect. Sorry.
Moss, yeah, I've heard of that. Yeah,
Yeah, and it's basically capturing radiation, taking the energy out and using it as a load, and then by doing so, you stop using the load as to where you want that element to result in. So let's say you had cesium 241, you pull the energy out until it reaches gold, and then you
right,
stop, and then you
right,
have gold as a byproduct. Now,
right.
I'm not trying to grow gold. That's not my point. I want silver, honestly, for electronics.
Yeah, but with their fusion reaction, uh, they were getting a whole bunch of different effects. It all depends on the type of isotope that they were putting, or the heavy metal that they were putting inside.
Yep,
So there's a whole range of stuff that they were getting: silver, copper, gold, platinum, uh, deuterium. They were making heavy water with this reaction as well, which I didn't know. Apparently, when you do regular electrolysis, okay,
yep.
when it's separating the hydrogen and the oxygen from the water, that water is changing to deuterium. It's actually changing into
Yes.
it's
And if
changing
you
into heavy water. Yeah,
and here's another part of it that I found out accidentally. If you keep refining that same water, if you keep using it, it turns into tritium.
yeah, yeah, exactly. And
Yeah.
that's a byproduct. And that's a byproduct of plutonium. Now, apparently, this device, if you have, say, a radioactive isotope inside the chamber, the Moxie reactor will actually destroy the radioactivity in it.
See, that's
So,
perfect. That's my goal. That's what I want. I want to be able to take
so
radioactivity and if I can't pull a load out of it, so be it. But I want to
no,
literally solve it.
no, you can create a huge amount of energy out of it. Depends on what
I
you put
believe you
in it.
can.
Yeah, you
But
can. These
even
guys,
sorry, go
like
ahead.
this guy Kevin Schwartz, that's in that interview with Jay Weinberg the other day. He said his ultimate goal was, making energy. So he's getting way more energy coming out than's actually going in. Now
See, that's perfect.
yeah, they're using the power supply. No, for the sodium lamps outside, though, the old street lights, the sodium lamps.
Yep.
Okay, they're using the power supply from one of those. That's what they're
Oh,
using.
okay.
Yeah.
Yeah.
So you can find a lot of those in surplus,
I
and
actually have a whole bunch of them. I used to grow food
there you
with them.
go. All
Yeah.
right, so there you go. You got the power plant for it. So that's what they're using. All you have to do is make a small chamber. They've actually built a whole bunch of them and sent them out to a bunch of governments around the world to say, okay, this reactor does work. You guys start playing with this. Here's a starter. Here's a little reactor. It's ready to go, and start playing with it and start making energy at a way cheaper cost, and it's safe.
I'm gonna have to
So
watch that video because this sounds
yeah,
very interesting.
yeah, watch that video. I'm telling you
This
right
is
now.
something I've been looking for. Like, I don't even care if somebody else found it and they're doing it and making billions. I don't care. I just want to be able to literally take radiation and make it inert. There's too
Yeah,
many people dying of,
yeah.
you know,
Well, there's too much
depleted
waste.
uranium
Period.
in certain countries. And if we could take even just taking the nuclear waste from Fukushima and
Yeah,
being able to
exactly.
literally transmute that into
Yeah,
nothing, man,
yeah.
that's worth its weight in gold.
For sure. It's a no-brainer.
Yeah,
And,
you'll save so many
and
people.
And the crazy part is you can make the reactor for under $100.
Oh,
Like
that's
hello,
awesome.
like come on, like really, like that's just unbelievable.
See,
I
and
mean,
I have a coil that I've been working on that, and this is just a theory now, but if my theory is correct, um, and of course I'm going to have to look at this new Moxie reactor. That sounds very interesting. Might go along with what I'm doing.
yeah,
But if my theory is correct, by using plasma and the way that this coil system works, I'm going to be able to capture that energy as it's transmuting, but I'll be able to define the element coming out, not just reduce the energy until the element gets to its daughter factor and keeps reducing. I want to be
yeah.
able to literally take the energy out in mass and define what the element's going to be at the exact same time. I may not be explaining that correctly, but that's the goal.
Yeah, I'm going to do a lot more research on this. It definitely caught my eye. Yeah, I was pretty blown away by the interview. So, yeah, definitely something I want to look into more because if you can make your own heavy water, that's incredible all on its own. Like you can purchase this stuff like deuterium, right? It costs like $50 a milliliter or something. Yeah, or it's some places it's pricey. Some places you can get it for a pretty cheap cost.
Okay, now deuterium, like, do you need a license to have that, or is that just a
No, as far as I know, heavy water, you don't need a license for it. Like all these elements that you need to make the system run, they're all in open source. Like there's no
okay?
like
Okay.
laws or regulations. All you need is an anode and a cathode and a pressurized chamber that has argon gas in it at 10 atmospheres. And then you put your elements inside and turn on the voltage and just let it spark away until it starts transmutating, creating heat or whatever elements you want to use, or what elements you want to extract. He's got a list there. If you go on the website there, on the YouTube, Jim Widener's YouTube channel, in the
Yeah.
description, it has a bunch of resource files there that you can download, and it'll give you all the information on all the different isotopes that were being created and transmutated, or about the X-ray problem, and it depends what you're putting inside. Now the other one
Right.
is radon gas. That was
Oh,
another
sorry.
thing, and that was another thing that what's his name, Fleischman and Pons didn't realize that it was when they opened it up, it was emitting 1,000 times more radon gas than the worst basement. So that was another reason why they got cancer too, is because of the radon.
Yeah, wasn't
So
there was a one of the scientists died? Well, of course, a couple of them died apparently, but in
oh,
the Martin Fleischmann Memorial, I think it was LENR. One of the scientists had passed away from cancer due to that.
yep, yep. It wouldn't surprise me for a second. And if you're not taking the proper safety precautions, yeah, you're going to have problems. Oh, the other guy that was creating this reactor and nobody knew about it, guess who it was?
Who?
And that's why, take a wild guess.
Mm,
Who's, it
I
starts
I
with an
got
S.
I
It
got
starts with
nothing.
Stanley Myers.
Oh,
That's 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 how his car worked. Everybody thought it was electrolysis. It was a Moxie fusion reactor. It was not electrolysis. He
that's
was using
interesting.
he was using deuterium water, argon gas inside the cylinder. So he made the spark plug. He would shoot through the spark plug the argon gas with the isotope in the stem, and he would zap it the second it went into the cylinder. That's where the power was coming from.
Okay, so there was something else that he had made, and I believe
Bubble.
he was using the argon gas for that.
That's right.
I'm
And
not sure about the car. That you could be correct, but there was
no,
something
they
called an EPG, and basically
yeah,
what's that?
yeah. Go on, sir.
Yes. So Stan Meyer's EPG was basically a half-inch copper tubing wrapped in three
Yep.
coils, and then he had
Yep.
coils wrapped around that, and he would pump
Yep.
gas through it at certain
Yep.
atmospheres, and it was
Yep.
magnetic, and he would collect the energy from the very flow of it. It was a
That's
pretty
right.
unique system.
Okay. It was basically what he did was a Moxie generator.
Wow. There's a story that was told by him and his wife, apparently, that he was testing it in his garage and he had it running and he had a 1500-watt load on it. And he went into the kitchen and talked to his wife for some reason. And they heard this big whoosh like a train and it
Uh-huh.
got super loud. And then their ears popped and then there was no sound. And he went out to the garage and shut it off right away. So
Yes.
basically, from the understanding was that the system breached the sound barrier because it
Wow.
was spinning so fast.
That's creepy.
That's crazy, right? Like, I mean, I
That's
don't know.
similar. That's similar to what happened to Floyd Sweet.
Oh yeah, perhaps.
Yeah. You might have broke the zero barrier or
That
caused
doesn't
that.
surprise me. When you're messing with magnetic electrostatic spin, crazy
Yeah.
things happen.
Yeah. So that argon gas is a key component to the Moxie generator. And when I heard him say Stanley Meyer, and I go, of course, that's where he was getting all the power from. Because
You know,
a regular electrolysis will not create enough gas to sustain an engine. Okay, there was some other element to it, and there was, like you said, there was that coil he made. The government went in and seized it from him.
yeah,
So
they offered him $300 million to run their tanks. He said no. He wanted it going to the public, and then I think it was 2 weeks later he was dead.
yeah,
Yeah. Mike does keeps trying to come in there. Hello, Mike. Just
What's
saying.
up, man?
yeah.
What's up, Gerald? Mike?
Not much. You.
Good, good.
Hanging in there, listening.
I hear you.
Yeah,
I
Hey,
have
about that
Stan
heavy,
Myers. Go ahead.
water. I think I know why he was using it. Because it's got more hydrogen.
well, yeah, it helps basically the electrolysis process to create not just electrolysis, is actual fusion.
More hydrogen gas.
Yeah,
Well,
Got
I
it's
more
know
actually
hydrogen.
creating fusion. It's creating fusion.
when I was doing my hydrogen experiments, I was lighting water on fire and imploding it like
Mhm.
firecrackers, and it would shake my windows like crazy. But after a while, and the water became conditioned, it became thick, almost like a gel. And
Yeah,
I
that's
believe
that's
both of
heavy
you
water.
are right. Yeah,
Yeah,
and
it's heavy
that's
water.
heavy water. Yeah,
Yeah,
Yeah, heavy
deuterium.
water is just more. It's two hydrogens.
Yeah,
It's a H two. H.
H3O2.
Yeah, there
H3O2.
you go. Right, that's
Yeah,
right.
yeah. And if
H3.
you keep conditioning that water, I believe
keep
it goes
using
to
it.
its next level, right?
Yeah, you got to keep using it over and over. You got to strain it out, clean it, purify it, put it back into the cell, run it again, and keep doing that. And eventually, you'll get deuterium, which is
Right.
right. And deuterium is H3O2.
Yeah, it's a thick water, almost gel-like.
Heavy. It's heavy water.
Actually, deuterium itself is two hydrogens bonded, I think,
That's
to
right.
each
It's
other.
fusing. It's fusing. It's changing.
There you
It's
go. That's
actually,
why you're saying fusion. Okay.
yeah, it's
Okay, so
transmutating it.
would you be able to get hydrogen from or not hydrogen, but
Yes.
or
That's
helium from deuterium if you were able to like
Yeah, because the
Eve-
hydrogen breaks down to helium.
Yeah, eventually, yeah. If you refine it enough and put it through the electrolysis and
Helium
cycle
is a
it,
byproduct of hydrogen burning, I think.
yeah, yeah.
that's
So,
interesting. I see I
so
don't
you
know my
just
chemistry that well, so you guys
see,
you got one
yeah.
on me.
I'm pretty novice with it too, but I did build the hydrogen generator back in 2004, and my water was turning yellow. I was using stainless steel plates. I had four stainless steel plates, and I was running it, and I noticed I was getting a lot of corrosion in there. But I did notice that the water was getting thicker, like you were saying. But at that time, I had no freaking idea what I was looking at. You know, like
Yeah, you and me both. At first, I had no idea what I was doing. I had stainless steel slinky, and I cut it in two pieces, and I wrapped it around four pieces of plastic so that it was like a spiral all the way
yeah,
in the cell. And
yeah,
this thing produced so much hydrogen, it was insane. And I had
yeah,
no idea what I was doing at first. That was around 2008. My
yeah. Just
first
do it.
video shows the cell, it's all rusted. I'm sorry, go ahead.
Yeah, just do it outside. Don't do it
Yeah,
indoors because you
yeah.
don't want that hydrogen to accumulate in the house. You're going to have sitting on a bomb.
Yeah, but you'd have to have a lot of hydrogen for it
Oh,
to
you'd be
blow up.
surprised. You'd be surprised. It doesn't take very much to make a big flash. Like I
Oh,
was able to make.
you're
Oh yeah.
not wrong.
Oh, and it's super fast too. It's one of the fastest ignitions that you've ever seen in your life. It's like instantaneous,
Yeah, that
explosion.
was actually the thing that made me jump back because I
Oh
figured
yeah.
it was going to pop off like soap and butane, right?
Oh yeah.
No, it's quick. And if
It's
it's a
super
big enough
fast.
bubble, it'll shake
What's
the
this
windows
soap
in
and
your house,
butane?
man. What's that?
What's,
What's this soap and butane thing?
Oh, it's just something I used to play with as a kid. It's not something I should probably talk about, actually.
was somebody a pyromaniac here or something?
Do you
I
ever
used to
blow up
like
those
to
spray
make
paint
things.
cans?
Yeah, you know what? We used to blow up a lot of things that we weren't supposed to when we were kids. You know, crazy stuff. Making your own gunpowder, that kind of thing.
Yeah, you know,
I used to
like the
take
kids.
gasoline, pour it in the bottom of a metal can, and put one of those almost empty spray paint bottles in the bottom there.
Oh,
It would just
nice.
boom straight up into the sky, about like I don't know, 150 feet.
Yeah.
Nice.
Took about
Uh,
3-4 minutes of the flame,
Yeah, I
the
don't even
heat.
want to say what the stuff that we used to do because it wasn't very legal back
It's
then.
better than just throwing the can away in the garbage. You know, you can use it as a rocket.
Yeah,
That's where you throw it out.
yeah. I used to play with rockets too. You
About
know
an
those
ounce of gasoline ought to
shells?
do it.
wake up
You
the
ever play with
neighbors.
those rockets?
Oh yeah,
Hobby
I play with
rockets.
many. Oh yeah, many of them. I set
We
many in the air.
we used to shoot them at each other.
Yeah, I made a bazooka out of one of them, like one of those, uh, kind of like the like an RPG.
They
I
look
don't know how
super.
healthy it is, but you can spray bug spray on your hand and light it up and keep your
Yep,
hand
that's
moving without
true.
burning.
That's true.
People think you're a
Well, you should.
magician and stuff.
You know
When
what?
it
You
comes
should.
to the rockets, just so that your audience knows, they don't hurt. Okay, they hit you and they fall down. They're not rockets.
Yeah, exactly.
They're hobby things. That's all.
We're
He
we're
just
giving
looked
way
really cool as bazookas. That's all.
we're, we're giving out way too much information right now.
Yeah, you're right. Yeah, my bad.
But yeah, like going back to this reactor, it just wow. When he explained it, it was just incredible what this thing
I
can do.
want one. That sounds amazing.
It doesn't cost much to make. You just have to worry about what's coming off it. And when I was working with the Don Smith device, I was working with Spark Gap, and
Yep.
I was starting to get a little bit worried because you are creating a spark, and it's 11 kVA. What I've read up on, they say X-rays need a minimum of 15 kVA to actually emit an X-ray. So I'm getting really close to the danger zone. So I kind of stopped doing that experiment just because I don't know exactly what's being emitted off it. Like I might work on it here and there, but when you're getting to everybody who's doing any of these experiments, you got to research some of the safety stuff, especially when it comes to like X-ray or beta or gamma. What's it being emitted,
Absolutely.
especially with the
Like,
old
couldn't you
asteroid.
just shield that spark gap with a piece of iron,
No, it
You
would
have
have to be lead. It would have to be lead.
lead?
yeah.
Yeah.
Iron won't block the X-ray.
No,
No.
no. It has to be lead. Lead
There's nothing
shielding.
other than lead.
Nope. Not that I know of, anyway.
I don't know. Maybe boron does, but or not boron, but
You'd have to
boron.
Water.
look.
But I could be wrong on that one.
You would
Water.
have to look it up.
Yeah.
But
Water.
if you know what, if you make a small, say, reactor, just build a small box made out of lead. I don't think it would cost too much. You could get these materials. You can buy the matting that they use for when you go get an X-ray at the doctor, like those aprons. All you
Yeah.
have to do is get one of those, cut one down, build a box for it, and basically just fill the whole box with the lead shielding, and you should be okay.
When it comes
So
to lead shielding, I still have a box of old lead shielding that they used to use for roofing to
yeah,
surround your chimney.
Right. You can
Yeah,
use
so I'm
that.
going to use some of that on my next system, but that's
and
interesting.
the other thing too that I found kind of interesting is they were also talking about radon gas. Now you can buy the test kits if anybody has a basement. I know here in Canada we all have basements and houses. Uh, we've actually done a radon test where you just basically open the cap of this bottle and just put it on your countertop and let it sit there for about, I think it's 2 days or 72 hours or whatever. And then you close it up, send it back to mail to the laboratory, and they'll do analysis on the radon exposure of the material inside the bottle, and it will give you a rating if it's a lot of radon gas or minimum radon gas, because radon comes from the earth too, right? This radioactive
Yeah,
gas.
yeah, and it fills
So
in your. It's heavier than air, so it'll sit in your basement and it'll fill it up. That's
that's
why we
right.
have radon tests. Yeah.
Yeah. So you can buy the kit. You can actually order them, and they'll deliver to your house. It's just a small bottle, about yay big.
Yeah, but
And
knowing my luck, I'll do the test as I'm doing experiments, and there'll be all kinds of stuff they find.
yeah,
I'm not saying they would, but knowing my luck, you never know.
yeah, yeah. You'll see a big truck show up at the front of your house.
Yeah, guys and
Guys
troops
coming out
jumping
in
out.
hazmat suits.
That wouldn't be a good situation. No.
Hey, Gerald,
Yeah.
what are you switching with? Transistors, reeds? What are you switching with?
Nothing right now. It's funny you ask. All week I've been doing this series of tests, and I've blown every transistor I have. So this morning I went and ordered another 30. Hopefully,
Oh, God.
it's because I got too much power, man. Like when I'm playing with, I'm trying to regulate, and it's difficult because
So you're not switching with a spark gap. You're using transistors.
I'm using transistors. Yeah, I want to switch to a spark gap. The problem is I'm getting very high potentials with just small amounts of copper. Like my coils, some of the smaller coils, I'm still producing 1800 volts with like 24 volts in, and the current is insane. That's why I'm blowing all these transistors.
Yeah.
If you were to
What
switch with
I,
a spark gap, how would you do it to
hold
keep
on
your
one sec.
frequency stable like the transistor does?
That's the problem. I'm not exactly sure. There's a couple of different ways, but like I could go mechanical sort of thing and do like a rotary spark gap, right?
Okay.
And
Here's the
maybe
spark.
adjust it like that.
Okay. Here's the spark gap switch that I use. It's the standard one you get from Canadian Tire. It's the RL44. This is what I'm using now. You can make
Right.
these
That one's
extremely.
controlled.
All right.
That's
So
controlled
what
by an
I
inductor inside there. It controls the speed, right?
well, well, no. You have the inductor that opens and closes the gap. All right. That is completely isolated from the actual
Right.
circuit.
Okay. Now I
Okay.
get it. Yeah, yeah,
It's
yeah.
an isolation. Yeah, it's isolated. So the
So you're
power
you're
that you
you're you're
use.
powering the inductor to control your switch, and that's your
Right.
isolation.
That's right. So here,
Right.
hold on
Okay.
a sec. I'll show you. I'll show you real fast here. Open this up.
So
Okay.
that's like the
So
mechanical.
yeah.
Okay, go ahead.
So these two pins here control the switch. All right. So
Yeah, that's the
basically,
coil in there. That gets energized, creates a magnetic
right.
field, then it
All
pushes
right.
the relay.
Now these two pins are normally open. Okay.
Right.
So you put the ohm meter there, it won't make the sound. The second you close this, induce the current here, it throws the switch, and then these are now connected. That's
Uh-huh.
how I that's how I trigger.
But
So I
that's
use
mechanical, not
And
solid.
what are you sending the 12 volts to that relay with? What are you using to send that to
well
12 volts to that?
that the 3D printer proximity sensor is connected right to these two pins.
Ah, okay. And
Okay,
what triggers
that
Oh,
what's triggering the proximity sensor? The what are you using to trigger that?
well, it's the magnet from the wheels. You know, the
The
wheel as
magnet.
it's
Okay.
spinning, right?
Oh, okay.
It's every time it passes through that proximity sensor, it closes the switch. It closes the switch. It completes the connection.
so you're basically
It
using a relay
energizes it, right?
switch. Yeah, you're using a relay switch as a transistor sort of thing. Yeah.
Basically, that's exactly what it is. I just made it into a mechanical form. Now, I've been able to bend one of the prongs over where the little lever flips over and makes contact. The
Yeah.
one that it touches to where the carbon's on it, you can actually bend it forward and make the switch fire faster. It has less distance to travel.
I
So
wonder if you could. Sorry, go ahead.
I've been able to get it to the point where it's so fast I don't even see an arc anymore. The arc's almost disappeared. That's very good.
That's
That means
smart. If you're trying to
okay.
avoid that arc,
I wonder if
Well,
you
to a point.
could you use solid state relay for the same thing? I wonder.
Yep, I have one, and I've been working with it.
how is the
It's
solid state relay working? Actually, it's not this. Is it the same thing as the car
I
relay, or is it
I
different?
think it's
no,
MOSFET.
no, yeah, it's a MOSFET inside or a BJT.
Yeah.
Uh, uh,
So then it's the
BJT
same thing as a
or
transistor, then.
basically, yeah. Like I have. Here's the one. Hold on, I'll show you the other one I got here.
So,
Yeah.
Gerald, going solid state, how's it going to help you if you're trying to avoid the
Okay,
burning out transistors? The
so
solid
one
state
thing I
relay will
have
burn out
noticed.
too.
I
So
don't
what
know.
I've what I've noticed,
It's
you
a
might want to
transistor
try.
in there.
No, you might want to try this, Gerald. This will might actually be better for you.
I actually
Okay.
have that exact. Oh no, not the exact same one. I have a 200 amp
Okay.
one.
Okay, that's good. That's good.
Yeah.
That's what you want. Higher amp, the better. So this one here is 100 amp
Hmm.
SSR. It's
Yeah.
super fast, and you hook this up. The two at the bottom is where you would connect your trigger or your signal generator to, and then
Yeah.
Five
all it does is,
volts.
and this will open and close. You'll complete the connection between
Oh,
these
you
two.
connect your signal generator to the
Yeah,
DC
This
it's
side,
volt
just
bit.
it's transistor.
this side, yeah. Transistor. You hook up the power, like
It's like the base and the
your.
emitter of a
Hold on,
transistor.
hold on,
Right.
hold on, hold on, hold on. This is basically the base of it, you hook up your signal generator to. These two, positive and negative.
Yeah.
That controls the top. It opens and closes the two, so it'd just be a straight wire going in, straight wire going out. That'd be your positive. Your negative would just bypass the whole circuit altogether. So it breaks right here.
Oh, that's beautiful. I'm gonna try. You know what?
And
You
I think
they're 20,
SSRs have more amps rating. They're better at
yeah.
amps, higher
Well,
amps.
this
yeah.
one's 100 amp. This one's 100 amp. If I go any lower, my Renegade device blows it up. So I have to
There's
use
no
a
such
minimum
thing as a
100 amp.
transistor that can reach 100 amps.
Well, apparently there is, but it's expensive. It's about
That's what
$21.
this. See, it says
Oh.
it says that it can handle an output voltage of 200 volts DC.
That's the
You
same
can't
price
get
as an
worse.
SSR, actually. I think they're the same.
This one here is $21 Canadian on Amazon.
Yeah.
Oh yeah, yeah. I spent I think 25 for mine or something like that on
Yeah,
Amazon.
so I would stick with the, if you 100 to a 200 amp, and the output voltage should be at least 200 volts DC. Input voltage will be 3 to 32 volts.
I
So your
never even
signal,
considered that.
yeah, try it.
Yeah, that's an awesome idea. Thanks.
There you go. Maybe
Yeah,
it'll
because
work.
I've had problems this week, man.
And
It's
and you know
hilarious.
what? They're super easy to install. Like it's four screws and you're done.
Yeah.
You can also
Oh,
put a diode on the facing out on the on
Yeah,
the trigger.
yeah, you could. Yeah, you could
yeah.
do it. Yeah.
I got something for you guys. So I blew this one transistor, but it's not blown. It's very weird. I can turn the circuit on, but I can't control the pulse rate to the transistor. So I
For
assume it's
duty
blown,
cycle.
right? But
For
Yeah, I
then I
think
duty
so.
hook
cycle.
up, but no,
Probably probably what happened is too much voltage got into the gate and has seized the gate. That's
that could be.
probably what happened.
Okay,
So
but
It
check
starts
out what
buzzing weird,
happens
right?
now.
so the
No, this
signal
is
that you know
go
what it
ahead.
is, Gerald, is be very careful on how much voltage is going into the gate. Now, some people like to put a 1K ohm resistor on the gate. That will protect it with a diode in only the direction that lower voltage is going to travel. So you got to check the rating. It'll have a
It will
sheet
look
that goes with it. It'll
the
show
higher
you.
resistance on your base will
Well,
lower your
no,
duty cycle.
well, what it's going to do is it's going to tell you what that gate rating is for how much voltage it can only handle. If it like a lot of them is only at 2 to 5 volts.
Yeah.
If you exceed 5 volts, there's a very good chance you're going to fry the gate.
Okay,
Then
well,
it's
that's probably
garbage.
what I did, but here's what
Yeah.
happens in the circuit now. If I hook up the coil and it goes through like a wattage meter, DC watt meter, and then it goes to 110 volt, 6 watt LED bulb, and it lights it up super bright, and there's
Yeah.
0 watts, and I can't
That's
understand it.
that's perfect. It's all
Yeah,
frequency going through.
but I'm not
So
using the frequency generator. It's not even pulsing. It just the minute I plug everything in, it turns on. So I know I fried the transistor,
yeah,
but
it's
it's very
well when
strange
it,
the way it's acting.
yeah, because what's happened if it's frozen in the closed position, is the second you put the power on, it's just going to have a straight connection to it. You know what I
Yeah,
mean?
that could be.
So that's one indication that if you put it say at a really low frequency, like 100 hertz or whatever, it should be blinking on and off, on and off.
Not
If it's
even. I stuck
if
it at
it's
1 hertz just to see. Nope,
yeah,
it's full on. So
yeah. So that means
Yeah,
it's
no,
fried.
the
Yeah, you fried the
transistor's
gate.
gone. It's
oh
gone.
yeah.
Yeah, yeah, you fried the gate. Yeah,
I just find it
it's still
weird that it's still at 0 watts and it runs 110 volt 6 watt bulb. It's really awesome.
Yeah, because it's shorted out. It's like a closed switch
Yeah,
thing.
yeah,
yeah, it's a
that's
close
exactly
circuit.
what it is.
Yeah, yeah.
I love
So
electronics.
yeah, try the SSR, man. Maybe you might have better success with it. And I've got it. I've
I think
been
what it
able
is
to.
about the SSR and the regular transistors is those diodes spacing out the emitter have higher amp ratings.
Yeah,
Yeah,
yeah, it's a higher amp rating. It's in a seal case. It's also got some good shielding on it from heat, so you don't have to worry about heat dissipation on it. You could actually buy heat sinks for these and put a fan on it if it is getting hot.
yeah,
So
that's why
there
the
is that
back's
option
metal
too.
way. Yeah.
That's right. Yeah, it's a mounting plate. All you do is get the silicone paste, put that on there, or the Teflon paste, put that on there, and then stick your heat sink right
Yeah,
on the back,
right. You still
and then
want a
you're
good heat sink.
yeah, and then
Yeah.
you're good to go. As long as you keep the gate from overheating, probably what
Hmm.
was happening is the inductor itself on the load side was probably heating up so bad it just fried the gate from the excessive heat.
In
So
my
it
circuit,
might, yeah, on your circuit, it could have
my
been,
my
it could have been
transistors
just a
don't get
thermal.
hot. I think it's just the voltage because my transistors don't get hot at all.
Now, the other thing too is what I'm thinking if you're creating a true radiant
Well,
energy or
okay, hold on.
thermal
I know what's going
energy,
on, Mike. You said your transistors aren't getting hot and they're still burning. You know what's going on there? You have to insulate the transistor from the heatsink because every time you touch the heatsink, and if you're grounded even a little bit while that thing's on, it's gone.
Oh
Yeah,
yeah,
no, I get what you mean.
oh
The
yeah.
heat sink, the heat
Oh
sink
right,
cannot be grounded, and it has to be insulated from the transistor with a mica
right,
sheet. Because if you
right, right.
accidentally touch it with your hand, not the transistor itself, the heat sink, and I've done this many times, and I'm like, what do you mean? Why does it stop working? It never got hot. And I'm like, this just like you. What? This thing never got hot. Why did it stop working all of a sudden? And I never put a mica insulator on the transistor on that one. Like,
So that
oh,
You
that
know
could
and
what
I
though?
touched
potentially be.
the heat sink with bare feet or sandals or whatever, you know.
I kind of wonder if that's what happened, but I'm not using a
Yeah.
heat sink. But I
Well,
grabbed the transistor.
then if you touch if you then the transistor itself is the heat sink, and if you touch it,
Oh, yeah,
it's
So
I
great.
tried
probably
it.
You ground you because the heat sink is also the collector, but you can't
I never
have
even.
a bigger heat sink. You know, a bigger heat sink being also the collector. It can be a heat sink, but it has to be insulated from the collector with a mica sheet, so the heat
probably
transmits,
what you
but not no conductivity though, just heat.
I can't believe
so
you just explained to me what I've been doing. I've been doing the
Yeah,
newbie mistake all week because I
yeah.
so
did my stuff in my garage and there's a carpet in there. And as soon as I
Yeah.
grabbed the
so
transistor, boom.
Don't touch the transistor with nothing. You gotta shield it or insulate it. The metal
Yeah,
part
so
of the transistor.
I
just
made the
just
newbie mistake.
just you know just screwed onto a piece of plastic or screwed onto a piece of wood. Like even if you have to screw it to something like that, just to
You know what?
isolate that,
Right, you could do
just
that too. Just so that
For
you
the
don't
just
get
to
longest
close to
time
it.
I was.
yeah,
For the
just
longest
to
time I
isolate
was
it.
doing that, and I got lazy this week, and I was just slapping it together because I was in a
Right,
hurry. And
right. Testing stuff out.
wow,
Right.
Yeah, it's a simple little thing that will actually
Yeah, I mean, if
cause
you
it
want to work
to.
like that and test out things without, properly securing the transistor like that, just be aware of the fact that if you touch the metal part of that transistor while you're working like that, you're
well, at least
probably
I know.
even with insulated shoes, you're probably gonna, if it's running when you touch it, it's gonna probably go bad.
Oh yeah, it was running every time.
Yeah. So
Yeah.
just don't go near it and turn it off before you go work on it. And even then, it still goes bad because it has, built up energy in there. Even when you turn it off, you have to have some kind of draining system before you start touching it again after you turn it off. Like
Well, I was in the middle of an amazing experiment. In
if it's
fact,
grounded, I guess.
I did something I probably shouldn't have done because I know I'm tapping.
Make sure your power
I don't
supply
know.
is grounded. Has a good ground. Your power supply for the systems. That
Oh
way,
yeah,
when you turn
everything
it
was
off,
grounded. Everything was set up right except for the transistor, right? Like even my power supply was grounded and my function generator was grounded. I wasn't worried about that. I had this system set up so that I had a ground counterpoise underneath, and I was pulsing it. And I'm telling you, it took me an hour and a half to get my energy back when I was done because it felt like it sucked the energy out of my body. And I will not configure it like that again.
Hmm.
did you get
So
shocked or something?
no, no. Just the way
Hmm.
that the system was running, I was playing with a certain type of coil, and I was trying to make it float above a magnet, like in my other video. But this coil is configured differently, and I just started to get tired and really like I needed to eat, right? So I shut the experiment down. And all of a sudden, my energy started to come back a little bit. And after an
Yeah.
hour and a half, my energy was fine. I'm not doing that experiment again. I don't know
Do you
what the
remember
heck
what frequency you were
happened.
running at?
Oh yeah, yeah.
What was
I
it?
write down all the parameters and I always record everything because I don't know what's
Well,
gonna happen, right?
you don't remember offhand.
Oh no, I do. I remember I was at 261 hertz. And that was at 1% duty cycle. But that's not the
261,
hertz. Yeah.
400 and
But see, now that's the thing. That's not the issue. The issue
520.
is the way that the system is built. I believe I drained the energy out of my body. I don't know. Maybe I was just
Yeah,
tired. I don't know.
261 hertz. I have to look up that frequency for the right frequencies. That might be a parasitics. You might be in like the danger zone.
You
They
know what?
call
It's
it.
funny though. The liver is sensitive to these frequencies. Certain frequencies can cause your liver to dump bile or to even detoxify, like trigger a detox.
Really?
Yeah. It's not. It's unknown unless the research is done. But the evidence
Yeah.
is there that the frequencies can trigger your liver to do things,
Well,
and not just your liver though, other organs too.
I was basically standing on the ground. So I was standing on the counterpoise, right? So it all went through me into the ground. So that's basically what happened. I won't be doing that.
Amazing.
Uh,
That's what I think happened. I'm not sure.
that's very possible because usually when I go in front of my motor, with if I sit there within about 15 minutes, I feel like I had a 9 hour sleep. I'm like totally
Well,
charged, and it'd be
rotating
like,
magnetic fields affect you. It's
yeah,
known fact.
mine's hit, mine's hitting a sweet spot. Whatever it's doing, man, does it charge you up? Like I mean, like it'll be 1 o'clock in the morning. It'll be like I just woke up after a 9 hour sleep, like
Normally
fully
that's how I
charged.
am too, but being in this new lab, it's different than in my house. My house, I have an iron pipe that goes directly underneath the house, and it's
Right?
grounded out down there. Whereas in my garage that I turned into a lab, that's a whole other story. There's no
Yeah.
ground system in there, so I think that I need
Right.
to rethink that
Mm,
because I built a counterpoise ground system, right? But it's still above ground,
mm.
so I don't know if that's quite the right thing to do.
Yeah. No, the same thing with me. I live right beside a railroad track, and I found out that's like the worst spot to do stuff. So this summer, when it gets nice out, I'm going to be taking some of this stuff to a good location where actually I want to do some experiments because the elevation's higher, and I'm going to see if I get higher outputs with the coils, which is supposedly it will work. So that's what Bedini says, that the coils get stronger at higher elevation. So I'm going to put that to the test.
I'm
So
heading out
yeah,
your way this summer for sure because
yeah, look
outside
that
of
up.
Toronto, there's actually a version of Wardenclyffe Tower that Tesla built, and I want to visit it.
Whereabouts in Ontario?
You
I'd
notice?
have to look at my notes for the exact town, but it was a spot that was supposed to be in coordination with his Wardenclyffe Tower on the other side of what's the name of that? The falls there,
Oh, oh, Niagara Falls.
Niagara
Niagara
Falls.
Falls. Yes,
Yeah, because I live about an hour's drive from Niagara Falls, so it's not far
it's
from
you
me.
know what? I bet you that tower's close to you.
Yeah,
And I
probably
don't
is.
know if
I'm
it's
just
still a tower. It's probably a museum now, or who knows
well,
if it's
I'm
You notice
basically
that
right.
tower that has a half circle on the top?
according to the
Because
pictures.
Yeah, it's a half circle, half a sine
I'm
wave.
like I'm very close to Hamilton, so I don't know if that rings a bell.
Why did
You know
Tesla
what?
have
I have to look
half
at.
a sine wave on top of the tower? He had half the top half of the sine wave. He
Well, the
left the
pictures
bottom
that
half.
it did look like that, but I don't know if it still does. Apparently, it was turned into a
Well, it
museum.
was built like a mushroom, right? Or like a
Oh
half
no,
of
the
a.
Wardenclyffe Tower, yeah, it was, but I don't know if he completed this one. I know it was in
No,
Toronto. I know like or it was outside of Toronto. I got the name of the town written down. I got the name of the street that it was at.
okay, okay,
Apparently,
get me that info.
I
Whenever you
will.
find it, shoot me an email because I'm basically right in the middle of the whole thing. You know,
Yeah, I know, and
yeah,
that's what I was thinking. Like, I'm gonna come out there this summer, and I want to
yeah.
go do an investigation and have a look. Right?
There's a lot of cool spots here. I could take you to the Tesla Monument in Niagara Falls, where they
Oh,
got this actual statue there, so you could actually get a picture with him with his statue.
that'd
So
be
yeah,
cool.
yeah, I know all the cool little locations. I know all the really interesting historical sites that was basically around that same time. They call it Niagara on the Lake area,
Oh yeah, yeah.
and that's where the Americans tried to invade Canada back then. And Laura Secord was the one who tipped off the Canadian soldiers that the Americans were going to invade. So they have Laura Secord's house is actually now a museum,
Oh
and
wow.
in Niagara on the Lake, the post office there. is the very first post office in Canada that ever was opened. It's right there. So there's a lot of historical stuff in that area. I know that area quite well.
Isn't that when Canada chased the states back to their White House and
Yep,
burned it down? Right.
yep, yep, exactly. Yep.
Crazy Canucks.
But yeah, a very, very big part of Canadian and American history happened right in that town. So I've been there numerous times, countless times. And
Yeah,
there's a lot
definitely
of ghosts.
check that out. That'd be awesome.
There's a lot of yeah, there's a lot of ghost tours in there. There's a lot of places there that are apparently haunted, like really bad. Yeah,
Okay, so now when it comes to ghosts, I have a theory on that. And if
hmm,
there's lots of ghosts around Niagara Falls, it makes one wonder if it had something to do with Tesla's work. Because remember, Tesla never completed his work, but
yeah,
not everybody knows what he was doing behind the scenes. I'm not sure if you're aware of all the tunnels that are in Niagara Falls.
yeah. That's where the what they call the Underground Railroad, where all the Black Americans were fleeing the U.S. into Canada for freedom, right?
Yeah, my
From the
family
slavery.
was directly involved in that. I know
Yeah,
some things about that. Yeah. But those tunnels was also known by Tesla.
yeah.
And it makes one wonder if he was using that for cabling or some form of experiments when he was trying to do his cross-border Wardenclyffe Tower system. Don't know.
Yeah,
Just a thought.
yeah.
I was
From
thinking
what I
maybe hydrogen in the air is the way they do that grounding.
I thought about that too. Hydrogen be the way of it kind of um, your electricity, but it also have to do with RF. It also has to do with I don't know. Maybe that's a form of electrical
could be,
transportation. I
So
don't know.
before you
yeah,
get to the actual your transmitter, before it can, your wireless transmitter, before it can get
I
to
think it would.
the real Earth, it connects to the air using the hydrogen to then ground to Earth,
Well,
and that
the
makes
hydrogen could,
the
yeah,
the tidal.
the hydrogen would act like a conduit. You know what I mean?
Yeah, it would. Yeah.
Something in the air is allowing wireless transmission to find path to ground, Earth ground.
Well, the very voltage gradient between ground and the stratosphere would allow that to act as a conduit too, because every 3 feet has the voltage potential of 100 volts. So if you go up 9 feet,
Hmm.
that's 300 volts.
Yeah,
Your
exactly.
conduit would act even better if it's
Yep.
going higher. So
That's why I want to do my coil experiments at this place in where near where I live. It's right at the base of the Niagara Escarpment. It's called Kelso or Rattlesnake Point is what we call it, and that's the base of the Niagara Escarpment, and it's a pretty big uh, elevation jump between where I live and the top of Rattlesnake Point. So I like to go up there. There's a few national parks up there where I could actually go and just bring my gear and sit in the parking lot kind of thing and do some tests. Drive a nice 5 foot grounding rod into the into the ground without somebody saying something. Yeah,
yeah,
you know.
it's an atmospheric experiment. That's all you have to say.
Now the other thing about this location that a lot of people didn't know, it was part of a huge underwater natural spring. years
Oh,
ago, years ago, they had it was basically right off one of the main roads on Campbellville Road, where it was basically a tap that just came out of the ground, and you were able to fill up your jugs of water of natural spring water.
how
About
much?
I would say about 10 years ago, the city came in and said, "Nope, you're not getting it," and cut off the pipeline.
How much you want to
No,
make a bet says that very same spring was the thing that Tesla was tapping for his ground line?
maybe. I would say that's a very good possibility. Yes.
Yeah, just
Because
because of its vicinity to where he was in New York and
that's
where
right.
the Ward Cliff Towers are around Niagara Falls.
Yeah,
Wow.
that's exactly what it is. I think he was using ground as the actual conduit, as making the ground system that could be several hundred miles wide. You know, the
Well, it's
longer
the
you branch out, it's like the roots of a tree, right? and picture all those roots as all these waterways under the ground. Well, if you tap into that, use that as a grounding system, holy man, you're really tapping into it.
Yeah, I believe
So
that's how the pyramids, it was part of the mechanism of the pyramids.
it
Same
was,
thing, they
it
use
was.
water from the River Nile as grounding.
I'm
Yeah. Oh,
I'm still convinced the pyramids are generating
yeah.
a
They have
signal,
look up.
signal wave of
Oh,
some kind.
Gerald, look up a
Yeah.
guy named. Look up this guy named Les Brown.
Oh,
He was.
I already have all of his information. Actually, I
Yeah.
studied him back in 2010. That guy's a
Yes.
genius in
Brown's
the
gas?
crystal sense. Okay, so this guy's named Les Brown. He was a scientist out of I think it was MIT. I can't remember. He built a
I'm just gonna.
30-foot. Go ahead.
I'm just gonna scoot out for a cigarette and tell Mike the story because I've already read all the stuff on him. So,
Okay,
all right.
absolutely. So he built this 30-foot pyramid out of 2x4s, right? And he goes on the inside of it and he attaches uh, cable to the top of the inside apex of the pyramid, and he has it come down to about 10 feet or about 6 feet above the ground, if I remember correctly. And then he has another cable that goes from a grounding rod
I
that he's
vaguely
found.
remember this.
Yeah, and then he grabs the cable from the grounding rod and the cable from the apex, goes to connect them together, and he gets shocked. Thrown 30 feet against the wall, wakes up an hour later with a burn on his
Well,
two
here's the
hands.
thing. Here's the thing. Okay, I don't have any doubt that geometry, when you get the angles right on the triangle, of
And the
course,
height.
whatever it is, 40, 45, 4 plus 5 is 9, right?
Yeah,
You know, what are the other triangle angles that are the only angles you can use to make a triangle, right? Is 45, 90 degrees, and 108.
yeah. Well, you can, yeah, yeah,
But
you're
hold
not
on.
wrong. A true
Now hold
triangle,
on.
you're not
Add
wrong. Yeah,
take now add those digits. 45 is what? 4 plus 5 is what? 9.
9.
And then what's the other angle for a triangle? 90 degrees, right?
Yeah.
Well, what's 9 plus 0? 9.
Uh, 9. Yeah, I was gonna say like
Okay,
9.
okay, hold on. What 108, 108 degrees, the isosceles angle.
Yeah. Well, if you add it up, it's
Oh wait,
technically 9.
isn't 27 another angle?
I'm not sure,
It is. It's part of the isosceles. 108 and
but
27. One
isn't I?
27 is right there. The little angle, the 27
Oh yeah,
angle.
yeah, yeah. Between the two on the
I think
bottom,
the 108 is at the top, right?
you could be right on that because it's
108
108
is the top
at
angle.
the
Well,
peak.
that's more than 90. That's more than 90 degrees there at the top. The top angle
I'd have to look that
of an
up.
isosceles. That's Pythagorean.
I think you're right. Yeah.
Now, without those angles, light doesn't communicate or
Okay, but what?
saturate
Okay,
or
but the base.
refract or whatever the terms they come up with for this light traveling. I
Yeah,
don't think it's traveling, man. I don't think light is traveling. I think light is saturating.
well, light and time are directly connected. It's something I don't
I don't.
mention
I
very
don't
often.
know. I don't know about that.
Yeah, I know most people don't. It's actually something that I recently have
I think that's
come across.
pseudoscience.
Maybe.
Pseudoscience, distractive. That's pseudo distractive science to get
See,
you
here's
off the
the thing
beaten
with
path.
that though, okay? Because I
I
have
believe every frequency, everything is a frequency of its own individually.
yeah.
Every form of energy, including gravity, has a unique frequency to it.
Okay, so I
Unique,
have a friend who worked.
unique.
I have a
Keyword.
friend who worked for oh, what's the name of that silly
Like the
company?
triangle, like the triangle. You can't have a triangle without those degrees. The the
Not a
triangle does
true
never
triangle, right?
forms. It never the points never meet without those angles. They just keep going and going and going. They never meet.
Well, you can make a triangle at any angle, but whether or not it's a true triangle, that's a whole other story.
Can you really?
Well, I guess they're all
We're
isosceles at
talking.
that
We're talking
point,
three. No, not 2D. Not 2D. 3D is the reality of things in
right? Okay, but
geometry.
now when it comes to
A
Les
2D
Brown,
a 2D triangle. I don't see how you can even make a 2D triangle
okay,
onto
but now
a flat
listen,
plane.
when it came to
Uh,
Les Brown, it was a four-sided pyramid, and it was 30 feet in the air. So at 30 feet, that voltage potential would be what?
Four-sided.
Right? So 100 foot or 100
That's a
volts
mind
per
twister.
3 feet. That's 1,000 volts. I don't know. What's the amps?
Oh, what
I
do you
guess
know
it
about the
depends on the flow.
triangle? Four sides. Four sides. How do you do that?
Well, that's the pyramid he built, four-sided pyramid.
Well, we know how to make a three-sided triangle very easily. But how do you, you know? Okay, so four sides. Okay, four sides. The only way to make a four-sided triangle is by separating 360 degrees by four. Am I not mistaken?
Not when you're making a pyramid, though.
I mean, if you want to go from top to the ground and you need a four even sides, you would just use a circle and split it into four to go
No,
four.
I mean like
And your
four
angle would
triangles,
be
right?
would be the 360 divided by four. What it was that? You know,
Well, when Les Brown did it, it was pretty interesting stuff. I'll tell you that.
that's
I want
90
to build
degrees.
one.
That's 90 degrees. A four-sided triangle is 90 degrees each side.
He used
What do you know?
he
What do you
know
know?
how know how he made his connection from the top.
This,
So what
he used a circle divided by four to make his triangle. 90 degrees each side.
yeah, equilateral triangle or
Four times nine is
equilateral.
360.
Yeah. So at the top of his pyramid, which he
But
actually did,
again, it's got to be a nine. Though. It's got to be a nine. You can't have an eight. An 8 degree. Eight.
I don't think the math was important to him. He wanted to build a device to test whether or not the pyramid itself had
Why are
anything
all
to
these
do with
builders of
electricity.
these devices landing on the number nine? Everything you see that's built of any builder, Les Brown, Tesla, blah, blah, it doesn't matter. It's always going to equal nine when you do these numbers to all their buildings. It's incredible.
But
yeah.
nine just
So
puts the three.
see what he had a copper wire twisted counterclockwise, okay, and at the top of the end of the coil, he had these little pieces of wire sticking out like little electrodes sticking out. Had it wound down, then on the floor he had a piece of 3 foot by 3 foot plywood, and he got I guess it'd be speaker cable, the two cables together, and he wrapped that round like a pancake coil, about I think it was 200 turns or whatever it was,
And he grounded
secured
it out.
everything. Well, that yeah, from there he grounded it into the ground plus two-inch long staples right into the floor, and then the open end at the top he connected a piece of sheep's wool. And when he made that connection from the top to the bottom, it blew him back 20 feet.
That's the part I forgot, the sheep's wool.
Yeah,
Okay, get
sheep's wool.
this. You know what's crazy here? When you divide a circle 5 times, guess what you get? You get 72.
Ha! 72. Nice.
What's 7 plus 2?
9. But what's 72 plus times 2? That's 144.
Yeah.
What did Tesla keep saying? 369.
Yeah,
You
but
know,
Tesla was
doesn't
saying that in reference, I think, to three-phase motors.
agree.
Well, I built a small pyramid. It's actually on my YouTube channel, and I connected a ground plate to a coil that I had dangling from the top, and then I went from the ground plate. I took the connection through my body, and I connected my other hand to a piece of plastic. I was getting 25 volts AC. That was the
That's crazy.
differential power. 25 volts AC.
That's awesome.
And it was only about a foot off the ground. It wasn't a big pyramid. It was like a foot and a half on the sides, and there was maybe a foot and a half on the height.
You had
And I
three
was
sides,
uh, no, four-sided.
so 90 degrees each side.
And
Yeah.
that's what makes me wonder if maybe Mike has something there. Maybe it's the degree or the angle
It
of that
sure is, man.
electrical
It
wave.
sure is. It sure
Because you
is.
got
You
to
know
think
why?
too, the Earth is spinning. So as it's spinning,
Yep.
and you have that angle
Well,
coming up, it's collecting. I don't know. It's
Right.
just a thought.
So, anyways, one thing I did find out: the best material to make a pyramid with, apparently, is
exactly
anything
the
that's
angle, Gerald, the spin angle, right?
the best material that I know of from some guys who've done extensive testing with it is anything dielectric, like PVC piping is good. Apparently, copper is not good. You don't want to build it with copper. He says you got
Really?
to build it with yeah, you got to build it with a dielectric PVC pipe,
A dielectric is,
styrene.
is an insulator that can be
That's right,
a very
right.
poor conductor that can
Well,
be polarized.
I used fiberglass when I transmuted that lead,
That's
if that's what you want to call it.
yeah, yep. That's good. Fiberglass is excellent.
Why do you
Yep.
think it needs to be such a poor conductor? Because I guess because this is a high potential
Well, see, if you're
that,
dealing with
that you're
etheric
reflecting
power,
against geometry.
see, if you're dealing with etheric power, and John Bandini did an experiment where he took it out, a neon bulb, had the one wire hooked up to it. When he touched just the case of the battery, that plastic conducted electricity. It actually turned the
Hmm.
light on.
Oh wow.
Oh
Yeah,
yeah, I remember that. Yeah.
yeah.
Well, yeah, it makes sense
Remember that?
because it's such a high potential. You know.
Etheric power is what I think is going into this generator. So the etheric power is actually latching on to the dielectric.
And when you see things short out dramatically and just blow up, that's because you had some very good conductivity to this etheric power for that very short
Even
time.
even
Yep,
even
I think so.
graphite's another good one. Any kind of styrene, plastic, anything, even glass can be used to build this. You make it out of glass. Glass is an
It's,
excellent dielectric.
yes, it is, and it has capacitance.
Yeah, exactly.
Makes you wonder
What would
why
you
they
use
had
as a what would you
churches
use as a
in the front
battery?
of glass.
Water?
What's that?
What do you think is a good battery for reactive power storage, other than a capacitor
I say
or
glass.
carbon?
Glasses, yeah,
Not
Yeah.
water?
yeah.
I
No, I would
don't
say
know.
glass.
I
Any
say
kind of
glass is
silicate,
better than water.
any kind of silicate.
What about water mixed with amino acids instead of
Mm,
like
No
normal
water.
amino acids like
Well,
taurine and
ac-
whatever?
actually, no. Would be actually really good is take water, and you get what do you call quartz crystal, and smash it down into a powder, and mix it in the water. And there you go. Now you're talking.
yeah, I kind of
Quar-
wonder about that.
Yeah,
There
quartz
was an
crystal would be.
Well, I
experiment
would
done
fill
by
the
T.
water
Townsend
container
Brown.
up to the top with quartz, all the way to the top, with water also, quartz and water,
And
but
that's
not
and
like
that
just a layer of quartz at the bottom. In other words,
because
you're filling it
Victor Shaw,
till you fill it all the way up to the top.
see
Of
Victor
course,
Schauberger when he was doing his experiments with his vortex, he was doping the
that's a
water
good
with
idea,
quartz
like
crystal,
quartz and water.
quartz crystal powder, and that's what Schauberger was doping his water with when he was doing those experiments. And at the very skinny part of the tornado is where he was extracting the power.
Well, that doesn't surprise me. T.
What do
Townsend
you?
Brown has this experiment where he takes a quartz crystal and he surrounds it by electromagnetic energy, and it starts to grow and expand, and it
Yeah, it's
loses weight.
alive.
Yeah,
It's alive.
and it loses weight. Well, see,
That's
now
what
here's the
Tesla
funny
says.
thing about that experiment. In the
Wait a minute.
Otis
Did you just say what I
car,
think you just said? He was
yeah,
making a quartz crystal grow.
yeah, by adding tons of high voltage electromagnetic energy into it. And
Maybe
not
that's
only
how
did
it
it
grows
grow,
naturally in the earth. Huh?
yeah, not only did it grow, it healed. So all the cracks that were inside it
Huh.
literally disappeared
Yeah,
and
it
it
grew
went
back.
crystal clear. And then it
That makes
started
you
to
wonder
grow.
where is the quartz getting its matter from to grow?
It's an interesting question.
If it's just getting fed the electricity, where's the actual? I guess it's
Not exactly
transmuting
sure.
electricity into its own matter. It's insane.
But if you look at that experiment for T. Townsend Brown, and then you look at Otis T. Carr and his explanation of his um, basically a spaceship, right? Uh,
It's all high
Ralph
voltage,
King,
and yeah, right. I got you.
Ralph King or Ralph Ring talks about. I can't remember his name. I think it's Ralph Ring. He
Yeah,
talks about
Ralph
the
Ring. I'm very
experiment.
familiar with his career.
Okay, well, when they sat in Otis T. Carr's ship, a crystal came out of the floor of the center of the ship,
Right, they were
and
illuminating it with some
yeah,
lasers.
luminescent light started to spin. And it makes me wonder if they use the fact that quartz crystal will grow and become somewhat um, lighter, right, after its growth. At least according to T. Townsend Brown.
I think the quartz crystal is
So it
being
makes
used to
one wonder.
resonate with another location where the craft would tune into.
That's possible.
Because there's quartz all over the universe, man.
I just got one of Tesla's books, and he's talking about
And the
uh,
light, the light, the
things.
light lasers
So
was using the light to get that tuning in to happen between two locations. And the craft would not, you wouldn't be able to decide where to go. The craft would just go to its ideal path or
well,
whatever.
see, now here's the thing. According to Otis T. Carr, it's actually the opposite. When the craft becomes translucent from that luminescent light spinning around the crystal, your spirit attaches to that craft, and where you think the craft is projected to, you go to, according to his account. I don't know how true it is, but if that's true, and the
See, that's a
ether,
different craft though, because Ralph Ring was working on another craft before that one, which was using the Utrons to spin
yeah, no,
aluminum
it's the
shaped.
same craft. It's the
It's the
exact
same
same craft.
one. They
Yep.
had the spinning
The
Utron
Utah,
and the
yeah, they
crystal
have
was
them
in the
all
same
around
craft.
the, yeah, they're around
Okay,
the
I didn't know that.
inside of the outside of the craft, right? And then there's one in the center. Yeah,
No,
it's
they
the
had
exact
four
same craft.
Utrons all around the craft, two on each four poles, spinning pieces of aluminum that were shaped like double tetrahedrons. They
Yep.
were held by electromagnetic Utron coils shaped like a U core with a coil wrapped around the straight arm to spin the aluminum double tetrahedron. They said they chose that shape because when you hold it at different angles, it would make different shapes known to man, like the
Okay,
square,
and
circle.
you're right. But if you followed the frame of that ship,
I didn't know that
at,
that same craft had the crystal in the middle also. I thought the crystal craft was a different craft
nope,
altogether.
same one.
It didn't have the Utrons in it.
Oh, I kind of wonder. You know what? You're making me think now. But
I don't
now,
know. I
according
think there were two
according to
different
Otis T.
projects.
Carr and Ralph Ring, they're the same ship. Maybe they're a different version of it. I kind of wonder. You
I
got
don't
me
know. I don't
thinking. I'm
remember
gonna have to look at my notes
I
now
don't remember it being the same craft.
because I have a documentary from Ralph Ring that describes it, and I got a somewhat
Maybe you're right. Maybe
bits
you're
and
right. It
pieces
is the
from
same
Otis T.
craft.
Carr.
So the Utron craft had the crystal in it also with the lights and lasers.
Well, the experience that was talked about from Ralph Ring,
Because the Utrons were used to create the resonance effect and the anti-gravity effect to get
yeah, I
them
wonder if that
the
was more
lift.
part of the motor,
And I think
right?
the crystal in the middle was for the transportation part, location allocation, the
Yeah,
device. Yeah.
or it's the biomechanical interaction between the person and the ship itself. So it
Yeah,
makes
the
the ship
mind.
alive by your very spirit.
Or both. You
Or
know,
both, maybe.
the pilot and the allocation directional. You know how to go from one point to the other. You're not steering nothing. I'm pretty sure of that. It's
See,
magnetic
and that,
or resonance controlled device. You know, it's controlled by the resonance of the cosmic boundary that's currently going
but see,
on
now that
whatever
would make
planet, wherever.
sense if you could control it through your spirit, so to speak.
With the
When
ley
you
lines on it.
turn, you wouldn't feel it because you'd be part of the ship. It would just be like turning your face or
Yeah,
turning direction while you're running on a football field. Do you know what I mean?
yeah,
Like
Yeah.
when you're part of the ship, you're not feeling any of the G forces because you
that's
are the
right.
ship. You're
Yeah,
mentally,
exactly.
you
You're
are it.
connected. You're
Yeah.
part of
So
ship. You're
to me, that it's something I've been theorizing about because it makes sense when it comes to doing those 90-degree angles that they do, or when they're gone at Mach 10. You know what I mean? And if there's people inside, essentially your organs would be mush.
yeah.
But why aren't they? And we
Well,
all
because I
theorize
heard
about
that
why
there, what I was
or
understand is
how.
that the occupants, what you're doing when you're traveling inside the craft is you're giving up minutes, not hours, not maybe a few hours, or less than an hour of your life to move around in space like that so fast in the craft for a few minutes, which would be giving up an hour of your life to do a few minutes of travel,
Yeah,
which would get
That's
you
an
like
interesting
across
thought.
the whatever. But what happens is the time differential is different because the energy density, the craft is creating a lot of energy, first of all, a lot of resonant energy. So the
Yeah,
density between the inside and the outside of that shield, of that barrier of energy, is also the density of time, I guess, if you want to look at it
yeah.
like
Well,
that.
there's your energy density on the inside of the craft where you are is
So where's the
completely
G
different.
forces? You're really moving. You're really moving through air, through the air. Like we're watching a UFO move around like crazy, right? But the people in there are moving around really slow. They're taking their time. They're doing like a Epcot Center run slow. Getting see how they come right up to you, take pictures of you. In their time, they're moving nice and slow, but you're actually frozen. You look like you're frozen on the outside of the craft to them because the time differential.
yeah,
Oh,
And
it's
that
yeah,
would explain it. That would explain how they can take people and they don't,
yeah.
because you're moving at a snail's pace in their reality, and in your reality, they're moving at light speed.
Or beyond light speed.
Well, they're
yeah.
not moving at light speed. That's the whole thing. Time is being sacrificed in the craft. The craft is blocking. It's
That's definitely
moving
an interesting
slow. It's the craft is moving slow. That's why the craft doesn't. They can successfully go all over the place and hardly ever crash. They have to be shot down.
I 100% agree with you that time is different on the inside due to your energy than the outside. Not only that, I
But
fully believe that there's
you're spinning up the wheel to a resonant RPM,
I think
and
there's
now
a double bubble.
you have this resonant field now being generated through centrifugal force, if you want to call it that.
Well,
But
I was talking about this with my son. I was explaining it's like a double bubble. So on the inside, your energy density is different than your outside. So you're in a bubble, but on the very edge, the very
and having
horizon,
more
the
energy
boundary
density would
layer.
also block G forces. You wouldn't have the effect. Not only are
Well,
you moving slower, so there's no G force. You're actually moving slow in your time.
yes, but on the boundary layer of
There's
the
no
first
G force.
bubble,
That's what I'm saying.
there's
There is no
another
G force for
bubble.
the occupants. They're moving slow. It looks like there's a lot of G force for them from the outside because on the outside, your time is moving at regular speed. But in the craft, time is slowed down. But
I get that.
biological time is not slowed down.
I'm
You're
just
still
trying
your
to explain
biological
the
time still
energy
remains the
density
same time.
differential between the inside and the outside. That's all.
In the craft, the time is slowed down, but the biological time of you in the craft is not slowed down. So you still experience an hour of time passing by. Whereas on the outside of the craft, they experience a minute. And that's why the craft can move around like that without needing blocking any G forces because they're not moving around fast. They're moving around very slow, like an Epcot Center ride. But you see them moving around fast because the time is it's
Yes,
being blocked.
every
It's a different
cell in their
time.
body, every atom is vibrating at a different
That leads
pace,
me to think
different
that
rate
time is weaker than gravity, or as weak
than
as
those
gravity. Well, of
observing from
course.
the outside.
I,
Absolutely.
I think time and gravity are both probably the
Well,
weak force.
they're the same. They're the weak force because what Dan Winters is getting to is basically saying that what causes time is spin and nothing else.
No, I don't agree with Dan Winter because of my experiments and what I've found recently. I would say that more it's light and time that are closer together than the
Yeah,
other.
but Gerald, light is spin. It's a frequency. It is a
Yes.
higher spin, a much higher spin, a
Yeah, yeah.
vibration. Vibration. If you don't want to call it spin, it's a vibration.
See, but now there's another part to that too, the biomechanics of our body and how we absorb light and how light can be used in our body. Like you go back into the luciferase thing, right? Well, that was found by somebody that I know, one of the scientists that was working for the same company that makes Roundup. I can't remember their name, but not off the top of my
Monsanto.
head. Thank you. He was working for them when he came up with the luciferase and how it works in comparison to light and our bodies and the biomechanics. It's amazing. So the information I got from that, coupled to what I learned about time recently, I would have to say personally, and I could be wrong. I've been wrong before. I think that time's closer to light than the other. That's
What
just
if
my.
time?
I could be
But
wrong.
frequency has a you know
Well, the other thing too is light travels in a linear fashion. So does
Does
time.
it though?
yeah.
Does
But
does
how would
time
you?
does light flow in a linear fashion, or does it flow linear through like more of a spiral
Well,
fashion?
that's
Just a
where the
thought.
spin is. That's where the
What
Yeah,
if
spin
right.
is.
time? What if time is the inverse of frequency, like being no frequency,
Mm-mm. Maybe you're
like
onto something.
as in no pulses, like and everything else that exists in time, it has frequency because time is a second, a minute, an hour, which are partitions of the frequency. So time has to be some kind of a outside the frequency. It's a carrier. It's the carrier for all frequencies.
What if time was an
That's how
energy?
I would define time as the carrier, not the carrier wave, but the medium upon which all frequencies generate themselves.
What if time was a form of energy that light rides on?
Sure, it's a carrier. Could
Well,
be, yeah.
light
Possible.
is part of the frequency, one of the frequencies of
Just a
all the
thought.
frequencies.
Just a thought.
So light
Yeah,
can carry on the time medium. And now is the time medium space itself though? That's another question. Is space the time?
is
But
or
you can't have
is
light without
or
time.
or how about this? It, who rides who? Does the light ride time, or does time ride the light?
Oh, maybe they ride together.
Well,
Right.
hold on. Light's everywhere. It's not isolated to one location. It's there's light
Right.
emanating from all kinds of locations.
Yeah, but
So
So
neither
it
is
doesn't.
you're
time. Time's not location. I mean, it is, or is it? Time's everywhere.
it's going in all directions, but if there's a
I
spin
don't think.
on
See,
it,
I don't
how?
think time requires matter to exist, or frequency, or anything.
Well,
While they've
It's.
proven light can create matter,
I think time is the byproduct of existence.
But without
Because you
movement,
can't have time. You can't have time without existence. You know,
okay,
you
but
can't
without
have
movement, there's no time.
things have to
And
exist for
without light,
time
you
to be
can't
a
have
factor.
movement.
That's right. That's right.
So the two are interconnected in some way, shape, or form.
Well, that's what I
Like,
meant.
if
That's
you
what I'm
ever
saying.
watch
That's what I'm saying.
water,
What if time does not require frequency to exist? It just requires. Well, you can't have frequency without matter. So there, you might be right. That's true. Time requires at least one atom of matter to be a factor. Because without matter, what's the purpose of time?
you're right,
Well,
but
I think.
without
Well,
light,
I think.
you can't see matter. It's not
I
Matter
think.
has
force.
no time has no purpose without matter. At least not to our mind.
Maybe consciousness is time. It's connected together. Because how would you be able to gauge
That's a
time
good
if
one,
you're
Mike.
not
That's a good one. Consciousness. You bring
right?
that one in, and now
Right.
matter is
Well,
not so important, is it?
yeah, the guy Stephen, he's on
Oh,
in
then
the chat
again,
board. He was the one who came up with that idea. So consciousness is time, and I would have to agree with that because how would you know
that's a
there's
good one.
time if there's nobody conscious to actually, you know what I mean,
Okay,
to
and
realize
and
that.
I think he's almost on it. Okay, that's very close to what I was trying to get to, but
So that would
not
explain
quite.
where we get
What if
our
consciousness?
our thoughts from.
Well,
The
what if
consciousness.
time is energy, but it's required for our consciousness to
Because look,
exist?
we can simply exist and have
That's right.
energy and not think at
That's
all,
right.
right? But we're thinking. You know,
Yeah, but you
we could
can't
be
think without
snails
time.
or whatever.
Hey, Mike, you can't think without time. It takes time to think.
That's right.
So, what if consciousness and time are the same as light in a way? Because how do you even have consciousness without light? And technically, you can't even be conscious without having
That's
time
right.
to think about that.
Right. So
So,
that means there has to be a life form or an intelligence to interpolate these effects of time and light. You have to have the consciousness there in order to interpolate. Okay, this is light. This is time. Because if there's no life form there, you know what I mean. There's nothing there
I do.
to assert, determine what's actually going on because there's nobody there, right? So consciousness has to be part of the time factor. You cannot have consciousness without time. You can
Right. So you can
dilate it,
have
you can
you can
alter
have
it.
time without matter. You can have time without energy. Only because we know consciousness exists, and you can have time without matter and energy because there's consciousness. And maybe energy is a form of consciousness. I don't know.
Sure
No.
it is. Sure it
Yeah,
is.
yeah.
Why does it have to be a form of energy? What if it's
We have a
beyond energy?
But that's just it, though. If consciousness is a form of
What if it's
energy,
a permanent recording that
no,
doesn't
I
require
disagree.
energy anymore? It's ingrained in the fabric of of
or our
uh,
well
of time.
our consciousness is 0 point. It exists.
Yeah,
It's there.
yeah, because
It
it
What
goes
if
it's
beyond
time
just
time.
is what if time is the recording the of the highest form of knowledge? And that's why the consciousness comes along with it.
see
And
you can't have implosion without consciousness. The result of consciousness is implosive, inductive.
But
So
again, that
when energy implodes, and it's happening in our brain right now, that's where our consciousness lies on the implosion. And this is kind of where Dan Winters gets into, which I have to agree with.
Dan Winters is the guy with the buckyball and the geometry thing, right? Right? He's all about
yeah.
that geometry thing.
Fractalfield.com. Yeah, he's out in
Fractal
Australia.
fields, right? Yeah, yeah. I just want to
Yeah,
make sure
he's
I'm
in
on the same
Australia.
ground.
I like Dan Winter's stuff, but the whole fractal field thing he believes is consciousness, and it isn't. It's just a mechanism for consciousness.
Okay,
Yeah,
here you go.
it's
Here
one.
you go.
It's
Here's an
one.
answer for what. Here's an answer for what what time might be. It's an angle. It's an angle. It's an
Oh,
angle.
yeah, maybe.
It's
I
an
think of it
angle of
more.
which the information can be perpetually.
I think of it more as an energy that can be imparted into the atoms of your body due to many different factors that I've researched, but one of them being when you get hurt, the voltage potential in the cells where you get hurt lower. So if you were to raise those voltage potentials and keep them at a high rate at all times, you wouldn't age in the same way as somebody who wasn't imparting energy into that. So I wonder if time is an energy itself. And as we grow older, that energy, through living in our consciousness and experiencing light and time and measurement, we use that energy up. But what if that energy could be replaced? Wouldn't that pause time or pause
Sure,
aging to some degree?
it would slow it down. It would slow it down.
Now, there's papers that just came out recently talking about how
Hmm.
age might be able to be slowed down due
Yep,
to the technology of med beds. Well, what's a med bed? Is it not just an energy system that imparts it into your body? I'm not exactly
You
sure.
guys ever heard of Baba Vanga?
ooh,
Baba Vanga.
Baba
Look
no,
her
Yaga?
up. Baba Vanga. She's a Bulgarian prophet.
Oh, yeah, she
And
predicted quite a few things actually.
she said that we'll discover immortality in like year 5,000 something. I'm like, she may be right. I'm thinking to myself, who the hell wants to live forever, man? You know,
Yeah,
like,
you know what? 1,000 years is good enough for me, man.
and even if they discovered it,
it.
who the hell wants to live even 300 years? You know?
I'd love to live 1,000 years, man. I'd become a painter.
Oh
I
yeah,
would
well, still
finish
a
my
thousand years, okay,
poetry,
but why would you want to
you
go
know?
even longer than that? You'd be
No, I don't know. Longer than
if
that
you
might be a
can't
bit
leave the
long.
planet, if you can't leave the planet and do some really cool stuff, you're gonna get bored out of your sick ass mind.
Yeah, but dude,
You're
there's so much to do
if you're
on this
not bored
planet.
now, if you're not bored now,
I'm not
give
bored
it a
now.
few
There's
hundred
so
years.
much to learn and see. Are you kidding? Look at everything that's underground we don't know
You're
about.
gonna need a
You
UFO
know?
craft,
Well,
and you're
maybe.
gonna need to be flying around to new planets just to be entertained for that.
Yeah, you could be right. I
It's
don't know. I'd love to live 1,000 years. I think that'd be a lot of fun. I get to
you
do
wouldn't
all
you
the.
wouldn't be able to do it on any planet, no matter how big.
I don't know.
You'd be
Moses
bored. You
lived
get
to
bored.
925.
Get hooked on
Noah lived to
phonics for 1,000 years.
975 years.
Your first 100 years, you've done seen Earth for sure.
I don't know. My first 100 years, man, I could get fat and lose weight 5 times.
And listen, even sooner than 100 years. You know, your first 15 years of life, you've done seen your planet. You know why? Because if you live in a society that discovered immortality, believe me, money doesn't exist, and travel is free.
No. Well, I
And
don't know
believe me,
about
you're growing up, you're going to experience your whole planet before you're 20, because it's free to go
I've
wherever you want to go.
experienced all of Canada, but I can't seem to get out of Canada, and I'm getting up there in the years, so I don't know about the first 15. I guess if you had a ton of money, maybe, or like you said, it was
Yeah,
free. If travel was free,
yeah.
And well,
Well,
I think
maybe
travel used to be free. I mean, I'm sorry, I think education used to be free before World War One in Europe. I
yeah,
think during the
education's changed.
Victorian.
It's not what it used to be. I don't
no,
have faith in
not
the
at all.
academic arenas anymore.
No,
I used to. I used to hold them in very high regard with tons of respect. And now, as far as I'm
it's been
concerned, they're
degraded.
bought and paid for shills. They don't
Yeah, it's.
they don't go after any new science. They don't try and disprove or
I know.
reprove. They
Yep.
just literally regurgitate. And it's sickening. Some of the
Yeah.
greatest scientists in the world have become pathetic in my mind. And who am I? I'm nobody. So my opinion doesn't really mean anything. It's just one man's opinion. But regardless, the
I'm sure
truth
there's a lot of
is
people that think the same way.
there's a lot of academic high end out there that just they've been paid off. They don't want to look at
Well, they've been Yeah, they've been paid off. They've been told this is the narrative, and you got to keep it. If you want your paycheck to keep coming in, you have to do this narrative.
Well, ultimately, that's what people go for their PhD for, right?
Yeah,
They're
exactly.
and once they get their PhD, then they can become an associate professor, and then they could
Yeah,
work at the university, and that's where they get paid. And then you get
yeah,
tenured. That's what everybody
yeah.
shoots for. Well,
You know,
we're the scientists.
well, the problem is they've turned academia from a learning institution into a job,
Yeah,
right? So, right. So all they want to do is be able to collect that paycheck every 2 weeks, and they're happy. They go by their narrative, and that's the problem with science now. It's become a
that's it.
job. It's not research anymore. It's a job.
Yeah, and they follow a narrative. As far as I'm concerned, I used to have a ton of respect for them. Now,
Yeah,
academia sounds like academia. They're all nuts.
yeah. They're all puppets. They're all puppets. They're all puppets.
Yep.
You get better education at a trade school.
Like real hardcore electrical engineering ended the day Steinmetz died. When Steinmetz died, there hasn't been real true engineering since.
We just do the same stuff over and over.
They're just
Electricity stayed the
rehashing.
same way for
They're just
120 years or something now.
yeah,
100 years.
yeah, yeah, 120 plus years. Yeah. So it's just rehashing old stuff. They haven't innovated nothing. Like a
I,
perfect example, they could save a ton of power right now on the power grid by changing the frequency of the street light from 60 hertz, change it to 200 hertz. Guess what? Your power consumption goes down by a huge factor. All right, like
yep.
stuff like that. You would save huge amount of money in utilities for powering the street lights outside or the lights for the road and all that. You know how much power is being sucked up from that stuff?
Oh,
Huge
yeah.
amount of power.
Yeah. They could do lots of different changes to make it more
Oh,
efficient. But
yeah,
ultimately,
change
it's
it.
like this: you're still going to pay because you're paying them, right?
Yeah,
I was having
yeah,
this discussion with somebody earlier today. If everybody had a free energy device, it's all about control ultimately, because
it is.
you're not paying them anymore. They're not getting their piece. Now, let's say I came up with free energy and I wanted to open a power plant. They'd be okay with that because then they get their taxes, they get their piece, I get paid, and the system keeps rolling. But if everybody was to have their own free energy device, there's no control over that. Nobody gets
That's
paid.
right.
We don't like that stuff.
Decentralize. That's what
Yep.
I've been preaching for a long time. They have to decentralize this stuff. We'll never move forward as a
What's up,
species
Anthony?
until we decentralize power. As soon as we decentralize power, the world will change in a
Yep.
positive direction.
Absolutely. We got to get the warmongers out of power, is basically what it is.
Yeah, exactly. It's just like you said, it all boils down to control, right?
Yeah, absolutely.
Control the masses.
We also have to come up with something that's going to be able to recycle these solar panels. You know how much that's
Oh,
going to be
did
worth?
oh. Speaking of which, you just jarred memory. There's
That's a lead intensive
our
industry.
Yeah.
yeah, they had a scientific breakthrough. They call it a scientific breakthrough. They've made a new solar panel. It's 1,000 times stronger than the solar panels on the market today.
Get
A
out.
thousand times. It's like
A thousand
40%
times.
stronger.
No, they said 1,000 times in the article.
What, the perovskites?
The polycrystalline solar panels. Yeah, they got ones. Apparently, they say it's 1,000 times stronger.
If
So
they
wait,
can
the
do that, it makes
polycrystalline, because the new thing is the monocrystalline.
Sorry, mono or poly. I forget which one it was, but they say
Monocrystalline.
yeah,
Polycrystalline is the
monocrystalline.
old technology.
Yeah,
They're trying to sell off that stuff still. Nobody's buying it. But the monocrystalline is the new technology. You're telling me they got 1,000 times stronger on that? That's incredible. I think it's
yeah.
40%, Mike. You're talking about the perovskite.
No,
Estimated.
this is no. I saw the news clipping today. Wish I could find it.
I remember seeing a video talking about solar recently.
Well,
I
if it's
didn't
not
know it was
perovskites, then
about.
I don't know what it is.
Let's
Yeah, I can't.
see.
I wish I could
But
find it
perovskites
here.
is not nothing new. It's old
It was on.
technology.
It was on
It's having
Google
a rebirth.
News.
Yeah,
It was on.
breakthrough solar panels are 1,000 times more powerful. Martin
No
Luther
way.
University, Hal Wittenberg have discovered
Yeah,
a new
that's it.
method to increase the efficiency of solar cells by a factor of 1,000. The team of
There we go.
scientists achieved this breakthrough by creating crystalline layers of barium
That's impossible.
titanate,
See,
strontium
barium
titanate,
titanate. Ah,
calcium
barium.
titanate, which
Hey,
were
barium.
alternately placed. Yeah, yeah,
Gerald,
there it is. Barium.
piezoelectrics.
Yeah,
Barium titanate. That's my
it's a lot.
transducer. There
Yeah.
you go. Ooh, you know what? That gives me an idea.
Hmm.
Oh yeah,
See, now,
I
if
have
that's
an
true,
idea.
then it makes free energy useless. 1,000 times more powerful? Are you kidding me? I'll
Well,
get
the
a
sun is free
freaking
energy.
solar panel.
Yeah.
The sun is
You know
free
what I
energy.
mean?
So they're using basically the same material I have in my transducers in my motor. See, and
Yeah.
that proves the power factor gain in my motor. If they're getting 1,000 times stronger by using barium titanate in the solar panel, that proves what's happening in my motor right there.
That's funny. Floyd
So
State
there's
was sweetened in barium also.
Well, I
I
wonder what that means though, because technically they have the strongest panel out there is 500 watts. So if they can do 1,000 times more, does that mean 5,000 watt
That's
solar panel?
50. That's 50,000 watts.
No, it's 5,000.
No. 500 watts times 1,000.
Oh, you're right. Yeah, my
it's
bad.
50.
That's 500,000.
All I got to see is I want to
That's
see.
500,000 watts, man.
That can't be right. That's fucking insane.
No, that's not right. This
No,
thing
I
will be
mean
like
just
the
the
size
fact
of
that
your hand and to give you your house.
yeah,
Like you would only need sunlight for 10 minutes every day, and then you can power your house for a week.
basically they
So
vape. That's crazy. I love it.
you know what? I
You know what
hope
are they
it's
going to sell
true.
that thing for? Dollar a watt.
Oh yeah, I
Dollar
bet
a
you.
watt.
I
That's what it
Probably
is
wonder.
now.
$10 a watt. Probably $10 a watt with that system if it's actually real.
If it's real, the public ain't gonna get their hands on it for years. It'll be
Yeah, and
military.
you know what?
A
You
house
know what?
only needs like 5 kilowatts during the day. Not even.
See, you know what? Some of
Yeah.
these big innovations, they keep coming back to my transducer, barium titanate. It
Well,
seems
seeing
to
that
be
barium titanate, that's something that was used in T.T. Brown's experiments
that's
as
right.
well. So
Exactly.
interesting.
Why do you think I've been using it for the last 2 years? Because I know it's putting out extra power. This is just
Yeah,
proving my point more.
I think I'm gonna
And
have to
everybody,
get one of those.
yeah, they're $11, man. They're $11 on Amazon. They're
You
about
know
an
what?
inch and a quarter diameter.
I'm gonna order one tonight.
No, order a couple of them. They'll work great with your coils. Put them in parallel with your coil, and then trigger it and watch what happens. I'm telling you, like
I'm
how
gonna
much
try it.
more proof you have to do it. I'm
Yeah,
telling you,
absolutely.
you got nothing to lose. I
You're
will
not wrong.
I'll send you $20 if it doesn't work. Because I'm
That's
out of
some
work.
confidence right there, bud.
Hey, I'm out of work right now. I'm laid off. You know.
That's even more confidence. What do you mean? That's great. Yeah, I'm gonna try that for sure.
Yeah, definitely. Because if they're using, see, I got the transducer. I got a small panel. I think it's 20 watts. I'm going to try hooking it up to it and see what happens. I'm very curious. Hook it up in parallel.
Well, the way that they say they made it is they did it in layers, right?
Yeah, they
And
layered
they
it. Yeah,
they used a laser to
to fuse it to the
yeah,
crystalline.
to fuse it into the layers. It's pretty interesting. Still reading it
Yeah,
though.
but still, it's barium titanate, piezoelectrics,
Yeah,
piezo,
they call
So
it
they're
piezoelectric.
just using the sun to rate to vibrate the barium, basically. That's it.
it's
You
Well,
got the
the,
ferroelectric
vibration going on. You
material
got the amp.
alternated with a paraelectric material. That's what they're saying.
What was that again?
It's a ferroelectric material that they're layering with a parametric material.
I don't know what parametric does.
Or yeah, I'm just reading
Somehow
here.
the sunlight is vibrating the barium.
sure, because there's heat. The molecules they're shaking. That's how you
I
create
guess
heat.
the barium is the
The molecules.
cathode, and they're using something else as the anode.
It's a
No?
paraelectric material, not parametric. Paraelectric material. I still don't know what that is, but hey,
Well, either the barium is
I'll
the
have to
anode
read.
or the cathode, and then something else is the other. And then you just tap
Yeah, well,
off.
they got calcium titanate, barium titanate, strontium titanate, and then it reverts back calcium titanate, barium titanate,
Yeah,
strontium. So it's layered
I
and
mean,
inverted. It's really interesting.
yeah, I'm using barium titanate in
So they
my
made the same materials to create one anode and one cathode. Just they inverted the layers.
Yeah,
It's a
that's what it
power
looks.
gain. See, to make
Just
a
like making a
thousand,
diode. It's just like making a diode. They're doing the same.
It
They're
well,
doping
yeah, allows the current to flow. That's what they're stating too.
from lesser conductivity to higher conductivity layers.
and that's why I've been seeing such a huge. Like the second I hooked up that transducer 2 years ago, right away I knew something
What's up,
very, very
Brandon?
special was going on. I
Wonder if you
knew
can make a
something was
pickup coil out of barium titanate. You know,
sure.
like a
That's what
like a
that's
ferrite
that's what
core.
they do. Yeah, they use it in guitars, like guitar pickups. They use transducers. That's what they can use, right?
Ah, I wonder if I should get myself a guitar pickup and
Yeah, it's
test.
just a diode. It's a piece of metal, round piece of thin metal, probably barium.
Yeah, barium titanate.
Yep.
Interesting.
Get those 1 1/4 inch barium titanate transducers on Amazon. It feels like ceramic.
What is it about the barium? Something
It's
It's a
the
high K electric.
yeah, it's just the properties of it.
highly
I
conductive.
record like with mine. The power of my motor went up. 40 to 50% more power output the second I hooked those up. It was instantaneous.
I love it. I'm gonna try it for sure.
I'm telling you, hook that sucker up to your coils, man, and you watch what happens. I guarantee you're gonna your hat's gonna flip off.
I'm gonna order a couple of those tonight, and I think I'm gonna order a couple of pickup
And
coils from
yeah,
for a guitar.
but the transducers that I have, the wafer ones that I'm telling you about, the 1 1/4 ones, barium
Yeah.
titanate, they work up to 42 kilocycles. So you
Ooh,
can
that's
go
quick.
real high. Yeah, they go up to a real high frequency. Yeah,
Yeah,
it
that'll come in
resonated.
handy for sure.
Yeah,
Well, this has been awesome, man. But I hate to bail, but I have to get up at 5. I got a catering job I got to do.
all right, man. Thanks for coming in.
This has been awesome. I,
Yeah,
I
the show.
apologize to the audience. I didn't get the experiments done and prepped for this evening's show, but I'm hoping that next week I'll be ready for you. This week was crazy for me. Lots of
Yeah,
contracts I had to do, so
I'm
I didn't
telling
have
you.
time to do my
Next,
experiments done.
next time you talk to me, I want you to have those freaking transducers.
Okay, you know what? You got it. The next time, next Friday, I'll have those transducers and we'll
Yeah.
do the experiment live. We'll do a test.
Yes, I want you to see it.
There, your
Second you
audience
see
heard
it,
it too. So
yeah. As soon as you see it, you won't go back.
there's a saying with that, and I'm gonna stay away
I
Did you
know.
from
see
it.
that Napoleon
Yeah,
movie?
yeah.
No, you?
No? Yeah, it was good.
Yeah.
You should watch it. It's good. Good acting. Very good acting.
Awesome.
Okay,
I think
Gerald.
Joaquin might even get the Grammy for that.
Maybe. All right. Thanks, Mike's.
Okay, Gerald. Yeah, yeah.
We'll
Mike's.
talk to you guys next Friday.
Plural. Yeah,
Have a good one.
yeah.
Thanks,
See you
If you
everybody.
later.
find anything out, send me an email.
Oh, yes, definitely I will. I'll dig that out for you.
Yeah.
All right.
Okay. Take care. Alrighty. So we'll do another 10 minutes here, and then we'll wrap up because it'll be a 2-hour show. So I gotta get up early. I gotta go visit Mr. Dentist tomorrow. So can't be up too late tonight. But yeah, definitely a cool conversation tonight. So I'm gonna backtrack a little bit. The Moxie generator, Moxie fusion reactor. I'm gonna dig into that some more. Pretty curious about it. Everybody can look it up online. Jay Widener did a really good interview with Kevin Schwartz. He was one of the guys that's been working on this Moxie reactor. It's MOXY reactor. And I'll give you a link here in a second. I'll put it in the live chat.
Moxie reactor? Never heard of it.
It's a Moxie fusion reactor. Jay Widener did an interview yesterday with this guy Steven Schwartz. Has been working on this thing. I'm gonna put some of the links here. I'll put the link. I'm going to put the link from rents.com. I'll put that link in. I'll put it in the chat so everybody can look at it. Oh, shoot. I don't know if that link's good. I think I got I don't know if that's the YouTube link. I don't know if that's gonna work, but we could try it. But it's on rents. It's the Moxie reactor, MOXY reactor. See, Anthony's asking, have Bandini things have you made the zero back EMF motor can be stopped and not draw any more power? Well, the idea with my system is I'm utilizing that back EMF. See, when you cut the power off in my switch, okay, you're breaking the physical connection between the potential or battery and the mass of the coil. So when that happens, is the current basically goes to zero. And that's why the batteries on my Renegade device don't kill the battery. Now, the back EMF now, as soon as that triggers and it gets cut off, it flips. Positive or south becomes north and north becomes south. It flips. And when that flips, that's when you get that burst of pulse. That burst pulse goes through my transducers and amplifies that power and shoots it out the back end. So it creates a reactance scenario, impulsive inductive reactance inside the coil. Like I'm pulling almost zero current off battery. It's basically just using the voltage potential from the battery to it's energy to mass. The second you put a lot of energy into a mass, that's where you get all the power. But if you could switch it really, really fast, hit the coil with it, and then shut it off in a nanosecond. And that's exactly what happens with my system. And when that happens, that creates the impulsive inductive reactance in the coil. I've cut the connection off between the power and the mass. So the current coming from the battery basically doesn't exist. It gets cut off to zero right away. So there's a lot of things happening right in that nanosecond when the connection's been broken. That's what happens. And that's why I get that bluish green radiant spike from my spark gap switch. That's where the radiant energy enters into the system. So it's all in the timing. If you get the timing done right, and I've learned a lot, especially in the last, I would say, 3 months on my timing and the switching is so critical. If you get it within 500 nanoseconds of accuracy, you're going to get the highest possible spike you can imagine. And like I said before, when that energy gets cut off, it flips. It actually flips. So it's a very interesting reaction that happens in my motor. And it took me a long time to actually figure out what actually is going on in it. It took a lot of digging. It took me 2 years of digging to figure it out. So
So you're
as
using
soon as you under,
your resistance on the base to get your timing right?
well, naturally there is a resistance in the system because the more coil you have obviously a larger mass, you're going to have more resistance, right? You have Ohm's resistance.
I mean, to control your
So,
duty cycle.
sorry?
To control your duty cycle, you're giving more resistance on the base.
Well, the duty cycle is very, very small because, the faster you trigger, the duty cycle decreases
Yeah.
substantially, goes lower, right? So it's basically just feeding off the voltage potential provided by the battery. That's why my batteries, I haven't charged them with a conventional charger for at least a month now. And the batteries have lost, actually, they've only lost maybe zero point 0.1, maybe zero point 0.2 volts in the last month. And I'm charging giant capacitors. Like today, I was charging a 16 volt, 500 farad supercap with this motor. And it's a small motor. Like I'm not talking a big scale here. This thing's very small. And and anybody who knows anything about capacitors, it takes a lot of current to charge up a multi-farad capacitor. It requires a lot of current to get that capacitor charged. So
Square are
try
cool.
so with the transducer comes into play, it's rebounding the power of the inductive reactance at a very high frequency. I've recorded as high as I think it was 4 kilohertz, 4 to 6 kilohertz range, and then
That's where you landed your tuning at was 6 kilohertz.
yeah, and that's where I get the huge spike in gain in power. My coil goes into resonance. I guess that's what's going on because that's the only thing that would explain why it has such a dramatic increase in power. You know, the second you hook up the transducers, it's lights on, man. It just
Six
takes off.
kilohertz
4 to 6 kilohertz. Yeah.
with a wheel.
Well, that's what the reverberation of the power and the reactance happening in the coil. It's bouncing back and forth between the transducer and the coil. It's doing this inside, back and forth, back and forth.
Oh,
It's resonating.
that's doing six. That's what's doing 6 kilohertz. But
Right.
your
It's
wheel's
the
not
fact.
doing 6 kilohertz.
No. It's only doing about 400 RPM, 4 to 600 RPM. I
Uh-huh.
usually try to keep it. I try to keep it under 600 RPM. Everybody thinks you have to wind it right out. I could crank it. I could crank it up to 2,000 RPM. It wouldn't make the system better. It would actually start drawing more current than you actually need. I got it at the speed right now where it's not drawing any current. And every meter I try to do an amp reading on it, it doesn't go low enough. It can't read it. It's too low. So yeah, very interesting phenomenon. But we could probably go for another 3 hours talking about this. We have been online for 2 hours. This will be posted in the Faraday Research channel under live. So if you miss part of the show, you can always go back to Faraday Research on YouTube and you can watch the show from the beginning. If you miss part of it or you just want to listen to it again and take notes, that's cool too. We'll be doing another live show again next Friday night, 9 o'clock Eastern, and hopefully we'll have Gerald back with his results. See if he did the transducers. I'm very curious to see what his results are going to be. I think that he's going to be pleasantly surprised. So we'll leave it at that. Mike, again, thanks a lot for joining in. And Gerald, thanks a lot for joining in for most of the show. That was really good. We covered a lot of great stuff tonight. Very good show. Guys that are regulars on the chat board, thanks a lot for tuning in and keeping the chat board active. And yeah, a lot of good feedback. Check out Mike's website on Faraday Research. Why don't you give out your channel there, Mike, to everybody who's listening? You got your link there. You can post it in the live chat so everybody can tune into your channel as well. Got it posted there.
Oh wait, I wasn't. Yeah, sorry. I had to join the chat.
Posted there, and then there you go. It's posted, everybody. I'll put it up on the screen here so you can see. And yeah, I think that's pretty much it for tonight. Thanks a lot, Mike. Thanks, Gerald, for putting on a great show tonight. A lot of great info. And yeah, we'll see everybody next week. Take care for now. Take care.